Hello and welcome to Podcast.init, the podcast about Python and the people who make it great. I would like to thank everyone who has donated to the show. Your contributions help us make the show sustainable. Linode is sponsoring us this week. Check them out at linode.com/podcastinit and get a $20 credit to try out their fast and reliable Linux virtual servers for your next project. We also have a returning sponsor this week. Rollbar is a service for tracking and aggregating your application errors so that you can find and fix the bugs in your application before your users notice they exist. Use the link rollbar.com/podcastinit to get 90 days and 300,000 errors for free on their Bootstrap plan. Hired is also sponsoring us this week. If you're looking for a job as a developer or designer, then Hired will bring the opportunities to you. Sign up at hired.com/podcastinit to double your signing bonus. You can also visit our site to subscribe to our show, sign up for our newsletter, read the show notes, and sign up for our discourse forum. To help other people find the show, you can leave a review on iTunes or Google Play Music and tell your friends and coworkers. Your hosts, as usual, are Tobias, Macey, and Patti, and today we're interviewing Alex Martelli. So, Alex, could you please introduce yourself?
Welcome, everybody. I'm Alex Martelli, Italian by birth and degree. I graduated in electronic engineering, did hardware for a while, then inevitably slid into software, entrepreneurship, management, and things. And then I met Python, and that changed my life. I got an offer to transfer from Italy to California to work for this little startup, which was a Python-heavy shop with a silly name, something like Google. And I took the risk. I've been living in California for 12 years, doing Python at Google. In the meantime, I've published a few editions of a few books about Python. I've been chosen as a fellow of the Python Software Foundation, won the Frank Wilson Memorial Award for contributions to Python, and I'm currently leading the one-to-many technical support group for the Google Cloud Platform, which is among the many Google teams that use Python heavily.
That's great. So, Alex, how did you get introduced to Python?
In the year 1999, I had just completed the copious spare time project of which I'm still proudest. It was an analysis of probabilities in the game of Contract Bridge. I had submitted the results of this analysis to the most prestigious journal in the field called the Bridge World, where it was published in January and February, 2 issues in 2000, with a foreword saying, some will say this makes giant strides towards solving problems that theoreticians had been wondering about ever since before Bridge was invented, and some will say it's much more significant than that. High praise. And at this point, I started getting requests from mostly famous Bridge people to asking if I could adapt my simulation and analysis environment for their Bridge problems. And I tried, but it was such an unholiness. It contained bits and pieces in Perl, but at the time my favorite language, C++, assembly code, because some parts needed to run really fast, Visual Basic, because they did need some kind of visual front end, Modular 3. Okay, let's stop listing because it was a mess. Anytime I changed a comma somewhere, something broke elsewhere. So I decided I really needed to recode it from scratch. A well-known trap which all software developers are prone to. Joel Spolsky highlighted that pretty well. It's a well-known anti-pattern. Nevertheless, given how fragile the whole thing was, I absolutely needed to. So I looked into some of the many languages I'd known and loved, from Scheme to Common Lisp, from Oberon to Modular 3, and couldn't find one that would give me easy access to things. And I was moaning about that to a colleague when said colleague said, "Oh, you should try this new Python language that seems to be really great." And I was like, "Oh, come on. The last thing I need is to add yet one more language to the mix. I need to simplify." "Well, you could recode everything in Python." "Yeah, right." Unfortunately, rather, I had a high respect for this guy. So eventually, when he got the first published book in Python, and before even opening it, loaned it to me so I could get how strong the language was, I gave it a try. The book was not that good, but the language seemed interesting. So having accidentally a long weekend available, I decided, let me try out the language and see how well I understand it. And since I'm at it, let me also write my first ever web application. That was at the time of CGI. I'd never written one before, but hey, if learning one thing is fun, learning two must be better, and three better still. So I started on Friday night, thinking by Sunday my wife and kids will be back, and I'll see how far along I've gotten. Of course, I'm not gonna finish the application, but hey, at least I have an idea about this new language and this newfangled web thingy, whether either or both of them are worth it. By Saturday night, I had completed all the website doing bridge computations that I wanted in Python, in CGI, and I had to start wondering, now what? Oh, wait, this is only an English site, and a lot of my the requests for using my stuff come from Italy, where I'm from, and France. I've got some roots in France as well. So I want to do English and Italian and French. I think I've read that templating is the right way to go to do a multi-language website. Let's see what's around for templating on Python. Looked around a bit, didn't like what I saw. There were a few, but hey. So I decided to write something to be called yet another Python templating utility, Yap2. And by about 11 a.m. on the Sunday, that was done too. I published it to Usenet. At the time, that's what you did with what we now call open source. The term hadn't been invented yet. We're talking about the 90s, remember? And that was appreciated. There was a guy who was busy rewriting the website for the University of Berkeley Computer Science Department, who had already decided to go with this newfangled Python thing and was looking for a templating utility, found mine, decided it was good enough to start, offered some patches, and that's how I made friends with Peter Norvig, best known as the author of the best-selling books on artificial intelligence and the director of research at Google, all through Python and this Yap2 thing. By that time, I was obviously captured. But that's not what we were using at work. We were a C++ shop with some Fortran and starting to experiment with Visual Basic and C#. So I slyly introduced Python among the cracks of those various languages, but I wasn't happy. I started trying to pay forward all the wonders that were Python by posting on Usenet. In a few months, a guy who would later go on to found the Python Software Foundation and is now my co-author in the third edition of Python in a Nutshell, tagged me the Martelli bot into the volume of my contributions and their mostly correct nature. On that basis, I contacted O'Reilly asking if I could write Python in a nutshell, and they said I'd have to do the Python cookbook first, but when that was done, I finally got to write the medicine, and the rest is history.
Well, that is quite an illustrious history you have there. That was a surprise appearance by Peter Norvig. I didn't realize that you had that connection.
That's how we made friends. Later, when I interviewed at Google, it was my lunchtime non-interview, taking me away from the heavy in technical levels that you're supposed to, if you have a friend there, to just make small conversation. It was even more technical than my interviews in the morning and afternoon, of course. Peter and I are kind of geek.
So one of the things that you mentioned early in your story there was that one of the ways that you got introduced to Python was through your interest in Bridge, and I had meant to ask you a bit about that. I know that Bridge is well known for being fairly complex and having a lot of theoretical aspects to it, but having never played it myself, I'm unfamiliar with some of the niceties thereof, so I don't know if you can take a few minutes to briefly explain maybe some of the background of Bridge and what it is that makes it so interesting.
At the age of 10, I was a promising junior chess player, and I already had what I still have today, which is an insane passion for books about anything, really, but what's interesting me most. And my parents very generously had opened a tab at the best local bookstore, so I could buy any book and then periodically go there and close my tab. So, of course, I was gradually, 1, 2, or 3 at a time, getting all the chess books they had. Unfortunately, they were mixing on the same shelf chess and bridge, so by mistake, I once got an intermediate to advanced bridge box. It didn't explain the rules, just intermediate to advanced things. I, of course, ended up reading it cover to cover and being absolutely fascinating and wanting to learn the rules of the game that gave rise to such fascinating situations as the book was explaining. I hadn't heard much about game theory at the time. It wasn't, it had been invented a long time ago, but it wasn't very much in the news. So I'd only read 2 or 3 books about it. But it did strike me that this was a case of incomplete information versus chess, which was a complete information game. And the incomplete information aspects were really fascinating. I mean, if you played bridge with open cards, you'd be playing a complete information game, actually simpler than chess, so it could be solved. It's also known as double dummy, and indeed, by the 90s, we already had very capable programs to play double dummy bridge. But since nobody's showing their cards, except the 1 player out of 4 called the dummy, that raises the interest and difficulty by orders of magnitude. So that's how I started. Then my parents, who had absolutely no interest in cards of any kind, introduced me to family friends who did. So I started playing on the Sunday afternoons at the friend's house and found it interesting, but the guys weren't really into it. It was more of a social occasion. So I found out there was a bridge club in my hometown, Bologna, and applied. And of course, given that I wasn't quite 12 yet, that at the time bridge was not considered a good game, an appropriate game for young kids. But fortunately, thanks to friends of my family and so on, I finally got approved and started spending my afternoons there. That didn't interfere with my schooling, which proceeded apace, but half my brain was into this fascinating bridge thing. So that's how I started. And throughout my high school years, I did great bridge. I actually played in the junior championships of my native Italy, which was and still is one of the great powers of international competitive bridge. I got 3rd place twice, bronze medals, not exactly the most satisfactory. Then I started university, that was engineering, and finally I found a professional endeavor that would actually soak up 100% of my time and energy. So from then on, my bridge has been of the on and off kind. possibly a good thing, because that's left me the time and energy to do other things, but the fascination never stopped. Part of it is that my birthday gift for my 14th birthday was a lifetime subscription to the Bridge World. The Bridge World at the time was offering it at a price that would have made a lot of sense if you were 65 or 70. So I inferred that getting it in my early teens was sure to be an incredible bargain. And for many decades now, I've been reading it for free every month. So that's how I got started with Bridge, and the actual problems that I tackled actually have to do with the simple part. Beyond the fact that it's not a complete information game, even if you saw all the cards, how would you deal with things? Or suppose you only see your cards, that's 13 out of the 52 in the pack, the other 39 could be distributed in only a few tens of million ways among the other partners. What if you did deal the other 39 cards in every possible way, solved each situation? Wouldn't that tell you a lot about the only 13 cards you can see? The first person who hypothesized that as a concept was Eli Culbertson in the 1920s. He was a rather fascinating guy, barely got out of jail in the early Russian Revolution, the 1905 one, thanks to the fact that his father was Scottish-American, but he loved Russia and hung out there until he had to run away to avoid the Tsar executing him or something. So anyway, if the proper way to judge of a bridge hand is to mentally play it in front of every possible combination of the other cards. That's conceptual, of course, because at the table you can't mentally play tens of millions of hands. But given a computer, was my thinking, you actually could. I mean, and you don't even need to play 30 million. You get a random sample at, 30,000 out of the 30 million. That essentially tells you everything you need to know about all the 30 million possibilities. So that's how I started programming in my not-so-copious spare time. At the time, I was a co-founder of a startup and a contract professor at a local university teaching numerical methods. So my spare time wasn't much, but it was enough as long as there was bridge involved. So I started hacking on that.
It's very interesting. And through your technical career, you've achieved a number of different honors and recognitions for various significant technical achievements. I'm wondering what kind of learning strategies you've used to enable you to achieve mastery of those various technical topics.
Interestingly, I found over the decades that what works best changed with time. In my teens and very early 20s, I had an incredible memory. Not eidetic, I never could remember where on the page something was written. It wasn't images. But for text and formulas, I essentially I made a nuisance of myself because I didn't realize not everybody could. If we were discussing and somebody said something and later said, because I said X and Y, I said, no, you said X prime, Y prime. The exact words that said, and that made a nuisance of myself, thinking they were trying to somehow lie to me, which was silly. So it was so easy to memorize stuff. That was zero effort. What I didn't have was the way to root whatever I'd just memorized off the page in real-world experience, because I didn't have enough, or any actually, as a younger kid. So that's despite the perfection of the memory, it's very shallow learning. I mean, you can memorize a poem, but if the poem talks about emotions, experiences you've never had, that's pretty meaningless. I mean, you have the words, but you don't have anything of what's real in the poem. And the same goes for, say, a programming language. Yes, you may know all of the rules of the programming language, but if you've never actually programmed to solve a real-world problem, that knowledge is sterile, just knowing all the words of a poem without understanding any of the feelings, emotions that are behind it. As I grow older, and by that I mean already by my mid-20s, memory became less perfect. On the other hand, I did start having real-world experiences to anchor my learning into. So it wasn't about memorizing 2 pages worth of tables of formulas and things. It was getting reasonably familiar with them and then tying them to something in the real world. And I found out that the more time goes on, the more I get real world experiential learning, the more important the strategy is to me. By now, I want to learn something. Sure, I still prefer to start with a reference manual. Now, most tutorials are written assuming you're a moron, which I'm not yet. I will eventually if I get old enough, I guess, but not yet. So I prefer to eschew tutorials, get all the rules from a reference manual, but then pick up some problem, including one that I have solved in the past with other technologies, and try and see how do I solve it with the new stuff that's being presented to me. Once I've actually used some technology, some approach, some tool for some real world application, my learning is better rooted. So I can go on that way. I think that's unique to me, but for many people, I believe that will be the case. If you just learn things by memorizing in the abstract, yeah, if you've got a good memory, you'll have that thing available for recall. But it's so much easier to check out a page in a book or a web page for all those formulas and rules. What those will never give you is how do you apply them. That starts telling you why is this feature there. Because it helps you solve this kind of problem more easily by this and that way. And yes, if you could get a perfect tutorial that would teach it to you, but I found out that I learn best when I have to find out for myself by applying the technology in question.
Yeah, as I've gotten more experience in various technologies, I've definitely found that the way that I approach learning has evolved because, like you said, when you first start off, you need to get a baseline understanding of some of the various fundamentals, but once you've committed that to your sort of baseline understanding of the topic, then you have a lot more scaffolding to build from, so you don't necessarily need to go to that level, and you can start straight with from the API documentation and have a better understanding of what's actually happening under the covers just intuitively because you've built it yourself or dug into it in other libraries or languages.
How do you keep the Python in a nutshell book current as aspects of the core language and its libraries change?
It's essentially rewrite every time, which is why what we're working on now is only the 3rd edition in over 12 years. It would be great to do a yearly edition, but every edition is almost a complete rewrite. So with other things in place, it doesn't really work. What I did this time is find 2 great co-authors, my wife, Anna Ravenscroft, and the guy I mentioned earlier, the founder of the Python Software Foundation, Steve Holden, with a very different set of experiences and knowledge than mine, so that we could work 6-handed and this way make it more likely that every corner of importance would be covered. I, of course, have been with Google almost 12 years now, so my understanding of modern Python is focused on how we use it at Google, which is important, but it's only partial. YouTube is Python head to toe, a lot of our infrastructure, and so on and so forth. But my wife and Steve have used Python or taught Python in completely different surroundings, so they have different opinions from mine about the things that really need to be covered. So with a 600 work, I think we achieve a better synergy. Indeed, we're almost done with a 3rd edition. It's already available in early release so ebooks for now only, from O'Reilly, but remember, O'Reilly ebooks are DRM free, so no risk. And if you buy the early release today, you'll get all upgrades until the final version. So I strongly recommend using a web search for Python Natural Early Release and see what's on. If at checkout you apply the discount code AUTHD, that'll be 50% off the list price. So I think it's quite a bargain. And you can send me feedback, and I can act on the feedback even drastically, because the book will be finalized. We've actually just got to the definitive deadline. It's 12th day, January 6th, known in my native Italy as La Befana, but a day to receive gifts as is 12th night. Except you don't need to get 12th drummer drumming or whatever it is you're supposed to get on day 12.
And one of the things that you're well known for is your prolific contributions to Stack Overflow, particularly on topics pertaining to Python. And I'm wondering if that was a specific goal that you had set for yourself, or if it's just something that happened organically as you learned things and decided to just try and contribute back.
I'd say more the latter. I had been in my Python career, I had been best known as the Martelli bot, being incredibly helpful on the Usenet group and mailing list Complang Python. Unfortunately, Usenet has been essentially completely taken over by spam, so hanging out there became totally unproductive. When Joel Spolsky came to visit Google and explain his new project, which he was about to launch, called Stack Overflow, I thought, assuming there's any interest there in Python, I could go back to the kind of fun I was having helping people on Complang Python back in the glory days of Usenet. So I signed up and started answering questions, and it just grew organically from there. At one point, my wife, despite being a Python fanatic herself, commented that we weren't doing anything outside of my workday anymore, because every minute of my time was going into posting on Stack Overflow. I said, well, it's kind of fun, but I can drop it any time. And she did typical wifely things, that is, challenged me. So, okay, so drop it now. And I did. I took a year off, and yes, I survived, and I did other things. We did like going to theater and other stuff we enjoy. Then, within Google, I got an offer to lead a team which is known as the one-to-many tech support for the Cloud Google platform. And it so happens that Stack Overflow is one of our main channels. So if I can ever get any cycle at work free from the leading and organizing aspect of the work, I'm actually getting to use work time to answer, as long as it's relevant to cloud, answer questions on Stack Overflow. So that's the happy ending. Well, not an ending really, but the happy state of things. Actually, in the last few months, I've been kind of very busy growing the team and mentoring people and so on. But I do plan to go back to Stack Overflow and do, I don't know, maybe 3/4 of my time on cloud issues, 1/4 on Python issues, something like that, and go back to the sheer joy of helping people, which is the main reason, the only real reason I've always been doing this kind of thing.
And when you're answering those Stack Overflow questions, do you usually already know the answer going into it? Or is it something that you typically have to sort of treat it as a learning opportunity and go out and find and figure out the answer before you post back?
Both situations happen. When Python is concerned, I would say I probably think I know the answer 80% of the time. It's still worth checking often, but and then there's that fraction of the time where I've never actually asked myself that question and I need to experiment a bit. For cloud, it's such a broader issue that it's more like 50-50. I don't know the answer anymore, possibly less than 50% of the time. So the other 50% of the time is definitely a learning opportunity. And being embedded in the tech support teams means that the sheer experimentation is not the only way I have to learn things. I often get the opportunity to just ask a lot of the people I'm sitting close to, which are the support geniuses of Google Cloud Platform, and then we're back to the 80% chance that they will know offhand and be able to give me a solution in 5 minutes without needing to research it. And if they don't know either, that's the most interesting part where we want to find out. Their time is mostly spent supporting premium customers who pay for support contracts. But, of course, if somebody else out in Stack Overflow land is having the problem, likelihood is that some premium customer will come up with the same problem sooner or later. So finding out how things are and how you solve the problem is a good investment of time anyway.
And what are some of the most difficult Python questions that you've been faced with on Stack Overflow?
Actually, not the important ones. Difficulty in Python, more often than not, by a big deal, comes up with when somebody's trying to do things in complicated ways that may sound natural to them because they come from other technologies, other languages, but are really unnatural and abstruse in Python, which makes them really hard. So more often than not, my natural reaction to getting one of those most hard question is don't do it. It's like the old joke, doctor, it hurts when I do it. Well then, don't do it. That once in a while, even though there's no practical application, a question comes up that resolves into me not being completely familiar with a certain internal deep part. Most of the time, it's stuff that's explicitly undefined in the language, so you're not supposed to rely on it. But of course, any given release, any given set of binary running your program, will have a solution. You shouldn't rely on that because any upgrade, any change in your Python release would break everything. But it's still interesting at a curiosity level to know what happens. One example, if I put n items in a set versus I put the same n items in a dictionary as keys with whatever values. When I loop over them, will the order be the same or not? That the order in which you get items when you loop on a set or dictionary is very explicitly undefined in Python. Think of it as random, but it's not actually random. It's whatever the underlying implementation dictates. So understanding whether the two are the same or not in a given implementation is really very hard to do because you need to study in depth the inner functioning of the data structures in the interpreter. It's of no practical use because you wouldn't ever rely on that because it could change in the next minor or point release. But that's probably the kind of thing that proves hardest to respond. And while the common sense me would say, so therefore just don't do it and pay no care, I am enough of a geek that if I get curious enough, I will research the issue and come up with the answer. Whether I post it or not, sometimes common sense
Right.
I don't.
Yeah, particularly in that instance, it's probably best to not give an answer because that'll just tempt them to use that knowledge and dig themselves a deeper hole.
We'll work in 351 and then 352 comes out, whoops, it breaks. So
Right. And particularly with the hashing algorithms concerned, it would even be different from machine to machine because of the differences in the memory architecture and the actual memory space available. So
exactly right. So the difficult questions are the ones that really shouldn't be answered. In Python, there are difficult questions in software development, whether you're using Python or Erlang or anything that have to do with human beings, because that's software development is a task done by a team of human beings. Human beings are so complicated, differently from the programming languages they use, that questions can be extremely difficult and extremely important at the same time. So, in a sense, managing or leading or just working in a team of developers is much more of a challenge than looping over a set.
In addition to your prolific posts to Stack Overflow, you've also presented at quite a number of different conferences and events about Python and various subjects having to do with software development. I'm wondering if you have any favorite talks among the bunch.
Well, on the cue offered by the end of my previous answer, I can't fail to point out that the best talks are only relatively little about Python or any specific technology. They're mostly about human beings developing software. Maybe my favorite, let's see, there are two I can't really choose between. One has been known as abstraction as leverage, or the Tower of Abstraction. If you use a web search for the video, you can find it under either title. Alex Martelli Abstraction will get you both. And it's about how do you properly design and use layers of abstraction. And people who say they don't are wrong, and I explain why, and so on and so forth. And then there's another one called Permission or Forgiveness, which explores the context and the depth of the famous talk, "It's better to get forgiveness than permission." This is true at many levels, I point out, and it doesn't work in certain situations involving, again, human beings. That's what we're all about. Problem with human beings is that we release 1.0 beta, and there's still plenty of bugs, and upgrades aren't coming, so we have to work around the bugs. Oh, and a third one, always on the same meta subject, that developing software is about a human activity. Is good enough is good enough. That, I don't know what order I would present these three. You'll find a little Python in each of them because I often presented them at Python conferences, so I needed an excuse. But it's really not the point of either of the three talks. If you want to focus on strictly Python stuff, there's a couple recent ones. One is Modern Python Patterns and Idioms, which refreshes my old, still good, but kind of surpassed talks on design patterns in Python, about what's the proper set of patterns and idioms in Python in 2015, 2016. And another one is how to handle exceptions and error in modern Python, which is something we should all know, but there's plenty, especially if you're moving from Python 2 to Python 3, there's plenty of subtleties people can easily miss, which are generally improvements in Python 3, but if you don't know about them, you're not going to be taking full advantage. The last of the 5 talks I've mentioned is actually a summary of Chapter 5 in the 3rd edition of Python in a nutshell, which, as I mentioned, is available in early release, but for 40 minutes of your time, you get the gist of what you should be doing to properly handle exceptions and errors in Python 3 in particular. So the last two are highly technical and near 100% Python. The first 3 are, I think, of more general interest because it's not just Python, it's human beings involved.
Yeah, and one of the themes that seems to be fairly common between them and a number of your other talks is the idea of design patterns and idiomatic code. And I'm curious what your thoughts and opinions are on why those are such important topics for developers to understand. And I'm also wondering if you can point out some of your favorite resources on the topic.
Polke's partner in founding Stack Overflow, Atwood, put it best. Don't reinvent the wheel unless what you're trying to do is understand how wheels work. The only reason to do your own thinking about a certain situation before researching what patterns have already been published and vetted is because you need to understand deeply the reasons under that patterns, which is a perfectly good motivation. But if what you're trying to do is solve a problem, an application level problem, whenever you can find an appropriate pattern published and vetted and commented on, you are saving yourself mental cycles so that you can apply them to the specific context of the application or infrastructure that you are developing. Let me just give a simple example. One of the modern patterns I mentioned in that talk. Modern patterns emerged in the last few years, tend to be architectural ones, so not specifically Python, because architecture is undergoing a revolution which has very few precedents. It may be the third big or fourth big wave of computing. Instead of programming for a single computer or a known set of computers in a data center, today you should be programming for a cloud of computers that can come and go, servers that you can enrich when you need and you can drop when you don't, and that changes everything. And one of the architectural patterns whereby you can best use this new richness is known as microservices. If you are not familiar with microservices, you haven't studied the vast literature about them, you start with some huge monolithic application, you will eventually need to reinvent microservices for yourself. That's a huge job. It will take you a lot of time and energy, and you may get it wrong because it's not trivial to get it right. Spend a few hours studying what all has been published on the subject, especially a little about how to do them in Python, but it's not really language specific. How do you divide the services? What can they share? As little as possible. How do you make them use each other? How do you test? How do you deploy? How do you upgrade? Blah, blah, blah. All those sort of things. Remember, it's not just development. Development and deployment, that's another relatively new idea, should go hand in hand. The term often used there is DevOps. Do you want to reinvent it from scratch? Well, okay, I understand, but it's like reinventing the wheel. It's been invented. It's out there in many forms with advantages, disadvantages. Why don't you just reuse the work of your predecessors? Remember what Newton wrote? If I can see a bit further, it's because I'm standing on the shoulders of giants. Wouldn't you like to be standing on the shoulders of giants and thereby being able to see even further than them? That's what understanding the state of the art in your discipline, which in software development and deployment is in good part embodied in patterns, not necessarily design patterns. There's design, architecture, deployment. Each has its own set of patterns, will let you stand on the shoulders of giants, which is what you should want to do and see much further and push the state of the art forward.
Well said. I don't have anything to add to that. That's definitely, like you said, by not having to reinvent the wheel and having a good understanding of where we've come from and what other people have already established as a recognized way of performing similar tasks definitely alleviates a lot of the cognitive load of creating the specific pieces of the application that are necessary for the business and frees up a lot of critical developer time in the process. And you've touched on it a little bit, but I'm wondering if you can go a bit more into what you see as the most influential trends in software development and design, both currently and heading into the future.
It's a dual-pronged push, which includes cloud and DevOps. Those are the two big keywords you'll find everything under. They work together because part of what cloud gives you, if you use it right, is reduce the trivial parts, trivial but still time-consuming parts of deployment operations work. I mean, maintaining a data center is a highly technical job, but it's also very time-consuming and repetitive. You have to be monitoring the servers, being ready with spares if one server goes bad, installing the replacement one, sending the broken one to maintenance so it can be refurbished. Keep an eye is it time to upgrade the switches for the local networks in my center. There's a lot of operational work that can be automated only in part, and is going to take superb technical people a lot of cycles. Now, when you move to cloud, you're essentially outsourcing all that work to teams at suppliers, such as Google, who have developed hundreds of many years' worth of procedures and methods to automate everything as much as possible on a scale of numbers of servers well beyond what your company's, orders of magnitude beyond what your company needs. So therefore, your operations work can move much closer to your development work, making DevOps not just a slogan, but a reality. The putting together developers and operations, once the drudge work of operations has been removed by offsourcing to good cloud suppliers like Google, is to solve the inherent tension between innovation and stability. To simplify and caricature a bit, what the developer wants is to finish the new feature and launch it, make it available to users. That's core motivation. I want to make users happy by adding this new feature and then the other new feature, and so on. What the operation people want is reliability. They want to avoid customers getting very unhappy by avoiding breakage, which is quite possibly going to come if a feature is launched without all the due proceeding. So where dev and ops meet is in a somewhat unfairly obscure area. It's been along for a long time, but it's finally getting to maturity and fruition, called release engineering. Work needs to proceed so that releases are precise and monitored and launched incrementally. So, for example, a crucial design pattern there is an advanced load balancer, which is able to take in user requests and send, say, 90% of them to the old stable system, and a fraction, say 10%, to the new, should be improved system, and monitor automatically that the performance of the new things is at least as good as that of the old and proven one, and so therefore gradually move all traffic to the new and improved stuff without risking a crash that strands a million travelers forever in 1,000 airports all around the world for days, just to give a very hypothetical example. Hypothetical, we all know.
I was a release engineer for over 15 years, so I totally agree with you. And it's interesting talking about how, sort of dovetailing your 2 points, in that modern DevOps culture is kind of in some ways an outgrowth of release engineering, right? Like, in order to...
is where the two big things meet,
right?
Because it's the only way to keep innovating while maintaining stability is to do clean, organized releases.
Right.
But it's crucial.
I absolutely agree. I think the industry has gone through a bit of a shift, though, in the sense that for a long time, release engineers, it was a very lucrative niche, but I think companies are no longer willing to employ people whose sole job in life is to do release engineering. I think most companies want people to wear more hats and to be more useful and functional in a broader way. So it's really interesting.
You may be right. I have not looked for a job as a release engineer in ever, actually. But what I see from some of my best release engineer friends is that their multiple hats are natural expansion of what release engineering is all about, which is reliability. Get reliable stuff, reliable systems from unreliable parts. Incidentally, there is a book that I have to recommend. It's amazing, even though I didn't do anything about writing it. It's called Software Reliability Engineering, published by O'Reilly, written by there's names on it, but it's dozens of software reliability engineers at Google who've contributed to it. I think if you read it, it will show you how release engineering is the heart, but a lot of other bits and pieces occur. For example, something that's not part of release engineering, traditional release engineering, let's say, is deliberately simulating crashes. That is, cause a certain data center, a certain fraction of the center, and so on, to crash and make sure the system as a whole degrades gracefully. That's something that's, I'm told, routinely done in other areas of engineering, such as airplanes are always tested so that, like big jets, if one engine fails, doesn't mean the airplane has to make it to destination, but it must not crash to the ground and kill everybody. It must be able to negotiate an emergency landing. That cult of reliability, which is extreme in aerospace, is finally, at long last, and it was time, invading the field of software. A lot of our software can actually be helping that plane fly, for example. So there's no reason to treat it more cavalierly than you would the wings or the engines.
And as a longtime computer and software engineer, sort of jumping topics a little bit, are there any features or ideas from other languages that you would like to see incorporated into Python?
Yeah, sometimes. However, one feature or language that I'd like to see more of in Python, it's unfeasible, mostly comes from C, but it was in Python at the beginning, which is to keep it small and simple. And the more stuff you add, the less small and simple the whole thing is, because you can hardly ever remove the old stuff, because when you do, it breaks existing programs, so you don't want to do that. And the move between Python 2 and Python 3 is proving lengthy and painful enough that it will be quite a long time before we dare do a Python 4 that removes excess complications. So while I would love to see certain things, like for example, I don't think our abstract-based classes are quite as powerful and complete as Haskell's type classes. Haskell's type classes is the best feature of Haskell. Well, it's got many great features, but the type classes, let me give you just one example, a trivial example that I love to give. I'd love to be able to say, as I can in Haskell, that some abstract type has a write method and a write lines method. Write takes a single string, write lines take a sequence of strings. And I would be able to say that the implementation of write is, in Python term, that would be self.writelines, open bracket, the single line, close bracket, parent. So a write is equivalent of a write lines on a single item list. Vice versa, the implementation of write lines is for line in the list, self-write line. This looks like a mutual dependency, but it is not. Given the class is abstract, the type class in Haskell, you have to implement one or the other, or both. But if you only implement one, the other one knows how to be implemented by using the type class definition. I'm not sure I've gotten the idea across. It could be a bit easier in writing, perhaps. But point is that mathematics is full of situations where essentially you're saying that these two operations are equivalent, so either could be defined in terms of the other. You have to define one of them more concretely, of course, because otherwise you've got a circular recursion with no end, no closure.
Yeah, I think you did a good job of explaining that. Essentially, you could kind of define it as being the transitive property of class definition.
We don't have that in abstract-based classes in Python. I don't have a clear idea of how to make it work right, but that's one thing I'd love to have if it didn't make Python any more complicated or any bigger.
So are there any questions or topics that you think we should cover before we close out?
think we've done a reasonable job, except we haven't really dug much into the human side of software development. I mentioned it a couple times. We may tend to think of ourselves as specialists in what we do, which is deploying and developing software. This is a good development, but it absolutely must not be the only one. It's like, let's put it this way. If it was Egypt, 2500 BC, we might be scribes, proud of our skills in getting the hieroglyphs just right with our style on papyrus. A crucial skill. However, wouldn't it be better if scribes were only called in for documents which actually require the scribe's exceptional writing skills? And most written notes could be penned by ordinary people, like a merchant just needing to send his agent over in Memphis the request to please send 50 jars of barley. Shouldn't need to go to a scribe and queue for the scribe's time and have beautiful hieroglyphs penned on papyrus and so on. They should just have some way of putting this very simple message on a piece of presumably papyrus, given it's Egypt, remember 2500 BC, and put it on a fast camel and have it go to Memphis and get the barley back. That is a caricature, but it's kind of the states where we are and are going. We have highly professional specialists totally focused on doing hopefully great software, and a lot of unmet demand for simpler but crucial bits and pieces of software, and people who are not programmers, but they may be excellent accountants, archivists, office managers, who really need something that works, but there's a queue of 3 years to get a request in front of the IT department, if you're lucky. The connection we're missing is that without any diminution of the professionality and the great skills that go into full-time software development and deployment, we really should be doing more to empower people with different professionalities, whether they're medical doctors or, as I said, office managers or store clerks or anything, to do simpler but effective pieces of software meeting their own needs. That dream started at least 50 years ago. It's never been made reality in the right way. I don't have a solution to this, but I think we should never forget the problem. We can become developers, deployers, and so on that are twice as good that would not solve the problem, because what percentage of the professionally educated population can be full-time developers? I don't know, 5%? 10%? So double that, it's still a tiny minority. The remaining 90+%, just like with today's technology and education, they can grab pen and paper and write a note in a hurry without it. It will not be grammatically perfect, the calligraphy will be inferior, whatever, but they can get the message across now rather than wait for the scribe. We need to make a similar jump, because today, being able to hack together a small piece of software, a simple piece of software, is the equivalent of writing a simple note in Egypt 2500 BC.
You know, it's really interesting. I've actually thought a fair bit about this because I feel like the Macintosh ecosystem actually made great strides toward this. I have admittedly only anecdotal evidence, but I have a fair bit of it that says that in the early days of the Mac, comparatively early days, with HyperCard, it achieved something like that. I've known a number of people who say that their relatives and families were able to build very useful HyperCard stacks with no pre-existing knowledge.
So we just failed to keep cultivating this. there's been a lot. I've heard about hypercards. I'm told the early days of VisiCalc, the very first spreadsheet, worked that way, at least for people with like accounting skills or the like.
So for anybody who wants to follow you and keep up to date with what you're working on, what would be the best way for them to do that?
I'm not very bought into the whole social media / blogosphere, so I'll try to do better in the future once the book is out, like maintain at least a blog to discuss the Python in a nutshell and related subjects. But for now, it's not something I'm going to spend cycles for until the nutshell is done.
So with that, we'll take it on into the picks. And my pick this week is going to be the movie The Great Gatsby with Leonardo DiCaprio. And it's a remake of an old movie, which is a retelling of an old book. And the modern version of it, I think, does a really good job of telling the story. It was very well put together, and the acting was superb. So I definitely recommend anybody who's interested take a look at it. And with that, I'll pass it to you, Chris.
My picks this week, I've only got a couple. My first pick is, once again, Stone Brewing, and they can do no wrong as far as I'm concerned. They make great beer. This week's is the Stone Ruination Double IPA. It's a beautiful IPA, nicely hoppy, really interesting, complex notes, very well balanced. It's just a great beer. So my second pick and last pick is a book that I've actually had on my shelf for quite a number of years, but I actually finally read recently. I'm about 3/4 of the way through it, and I really love it. It's called Ghost Soldiers, and it is about the soldiers who survived imprisonment in the Philippines during World War II by the Japanese, and the Bataan Death March, and their eventual rescue from prison camp, and some of the horrific conditions that they lived under. It's really quite a reality check when you're sort of feeling whiny about your day-to-day life. It's like, no, you really, chances are you've got it pretty cushy. These guys can show you how bad things can get. But it's a really great book, very much worth reading. That's it for me. Alex, what do you have for picks?
Can I also ask a question about your pick? Because I remember the original, not the original, one of the many remakes of The Great Gatsby, Robert Redford and Mia Farrow, and Francis Ford Coppola as the screenwriter, as really hard to surpass. Would you say DiCaprio, and who's playing with him?
I don't remember the actress's name, but having not seen the original, I can't give a fair estimation of that. I will have to remedy that soon.
All right, I'll at this point I'll have to go see it just because. Anyway, my pick is a book out of which the most successful and most unlikely musical comedy of these days has been made. It's Alexander Hamilton's biography, a heavy, ponderous tome that inspired Miranda to put it in music. He just couldn't believe that this dusty old founding father had such an incredible life. So whether you've already seen the musical Hamilton or not, you owe it to yourself to get Ron Chernow's biography titled Alexander Hamilton and give it a read. It's amazingly well written. My wife and I enjoyed it enormously before the musical went out, and when the musical got out, I said, wouldn't it be fun if this was a popular success? And it so happens it broke all records of popular success. But that's, okay, great music, acting, and so on. But the story itself in Chernow's book comes up so powerfully, so richly. This impoverished orphan from the Caribbean, making it nearly to the top of American politics.
All right. Well, we definitely appreciate you taking the time out of your day to join us and tell us about your history with Python and a lot of the work that you've put into it in the community. So, just thank you very much, and I hope you enjoy the rest of your evening.
Thank you for having me. Bye now.
Good night.